Today we will see examples from exercise 3.2c. The first example is integration of 3x plus 4 upon x square plus 6x plus 5 dx. So let I be the given integral. Here the numerator is expressed as a into derivative of the denominator plus b. So 3x plus 4 is equal to a times d by dx of x square plus 6x plus 5 plus 4. Therefore, 3x plus 4 is equal to a times 2x plus 6 plus b. Now, 3x plus 4 is equal to 2a into x plus 6a plus b. That means 2a is 3 and 6a plus b is 4. So equating the coefficients of the like terms, we get 2a is equal to 3 and 6a plus b is equal to 4. So a is equal to 3 upon 2 and 6 times 3 by 2 plus b is equal to 4. So b is equal to minus 5. Using these two values, we get 3x plus 4 as 3 by 2 into 2x plus 6 plus minus 5. So replace the numerator by this term and separately divide the denominator. Then we get this integral. So it is actually in the form of f dash of x upon f of x. So you can use it log of denominator or use the substitution. Put x square plus 6x plus 5 is equal to t. So this is I1 integral, this is I2 integral. Now take the first integral. I1 is equal to 2x plus 6 upon x square plus 6x plus 5. Use a substitution, or just I told you, use f dash of x upon f of x dx is equal to log of modulus of f of x plus c. You will get the integral of the first integration. Now the second integral, I2 is equal to integration of 1 upon x square plus 6x plus 5. Here the coefficient of x square is 1. So we don't need to take anything common. So just add the last term. And the last term is 9. How? Because 1 upon 2 times the coefficient of x. So 1 upon 2 times 6 is 3 and its square is 9. So you have to add and subtract 9 only. So you get x plus 3 bracket square minus 2 square. So it is in the form of the integral is 1 upon x square minus a square. Its integral is 1 upon 2a log of x minus a upon x plus a plus c. So 1 upon 4 log of x modulus of x plus 1 upon x plus 5 plus c2. So use this equation 1, 2 and 3, 4. We get 1 3 by 2 log of x square plus 6x plus 5 minus 5 upon 4 log of x plus 1 upon x plus 5 plus c, where this c is a 3 by 2 c1 minus 5 c2, because first integral contains c1 and I1. We are multiplying this I1 by 3 by 2. So this c1 also get multiplied by 3 by 2. And this I2 we are multiplying by 5 minus 5. So here this C2 is also multiplied by minus 5. So take their addition. This constant is a new constant, say C. The next example is 2x plus 1 upon x square plus 4x minus 5. Express numerator as a into d by dx of denominator plus b. So 2x plus 1 into a times 2x plus 4 plus b. So 2x plus 1 is equal to 2ax plus 4a plus b. Equating the coefficient of x, we get 2a is equal to 2 and 4a plus b is equal to 1. Now a is equal to 1 implies b is equal to minus 3. So I is equal to 1 into 2x plus 4 plus minus 3 upon x square plus 4x minus 5. So we have expressed this numerator using derivative of the denominator. Now separately divide this. Here this is the first integral and this is the second integral. This first integral, you can here also you can write it as I is equal to log of x square plus 4x minus 5 minus 3 times I1. So this is your I1. So making it perfect square, you can continue this here only, no problem, no need to say I1 and I2. Okay, so the integral of this function is log of denominator, because it is in the form of f dash of x upon f of x. And the second integral is we have to completing the square. So plus 4 minus 4 minus 4 minus 5 is minus 9. It is 3 square. So 1 upon x square minus a square is 1 upon 2a log of x minus a upon x plus a. Use the formula, you will get the integration 1 upon 6 log of x minus 1 upon x plus 5 plus c2. Use these two integrals in that equation. You get log of modulus of x square plus 4x minus 5 minus 3 by 6 log of modulus of x minus 1 upon x plus 5 plus c, where c is again 3 by 2 c1 minus 5 times. So no, not that c1 is here, the c is c1 minus 3c2. So log of modulus of x square plus 4x minus 5 minus 1 upon 2 log of modulus of x minus 1 upon x plus 5 plus c is the integration. Now the next example is 2x plus 1, 2x plus 3 upon 2x square plus 3 minus 1. So again, we are expressing the numerator using the derivative of the denominator as multiply this bracket by a and equating the like terms from both the sides. You will get 4a is equal to 2 and 3a plus b is equal to 3. Now this divide this 2 by 4, you get a is equal to 1 by 2, which implies this b is equal to 1. Use these from values in equation number 1. Our integral becomes 1 upon 2 4x plus 3 plus 1 upon 2x square plus 3x minus 1 dx. Therefore, I is equal to integration of 1 upon 2 4x plus 3 upon 2x square plus 3x minus 1 dx plus integration of 1 upon 2x square plus 3x minus 1. So therefore, I is equal to 1 upon 2 into f dash of x upon f of x. Call this as I1 and this as I2. So 1 upon 2 I1 plus I2. Okay. Now take this I1. Use f dash of x upon f of x, or you can use substitution. Put 2x square plus 3x minus 1 is equal to t. So 4x plus 3 dx is dt. Okay, you can go by like this, that or this. So, or you can directly use the formula f dash of x upon f of x is log of f of x plus c. Take the second integral. Now here the coefficient of x square is 2. So we have to take it common like this. Then we will take this half. Then the last term is adjusted by this 1 by 2 into 3 by 2 bracket square, that is 3 by 4 bracket square is 9 by 16. So add 9 by 16, subtract 9 by 16. So first bracket gives us x plus 3 by 4 bracket square, and the second is minus root 17 upon 4 bracket square. So I2 is equal to 1 upon 2 into 1 upon 2 root 17 by 4, because here 1 upon x square minus a square is there. So we have to use the formula 1 upon 2a log of x minus a upon x plus a. So after simplifying it, you will get this integral. So using all these integrals in that formula, you will get the integral of the form log of modulus of 2x square plus 3x minus 1 minus this factor, where we have written the c because of c is equal to 1 by 2 c1 plus c2. So the integral of the given function is so the integral of the given function is 1 upon 2 log of modulus of 2x square plus 3x minus 1 plus or minus 1 upon root 17 log of 4x plus 3 minus root 17 upon 4x plus 3 plus root 17 plus c. Now the next example is 3x plus 4 upon root 2x square plus 2x plus 1. So again here we will express the numerator as a times the derivative of the denominator plus a constant. So equating the like terms, we get 4a is equal to 3 and 2a plus b is equal to 4. Then a is equal to 3 by 4, and after putting a in this equation, you will get b is equal to 5 by 2. So we are expressing the numerator 3x plus 4 as 3 by 4 into 4x plus 2 plus 5 by 2. This 4x plus 2 is nothing but the derivative of the term which is present at the denominator. Okay, so separately divide, you get 3 by 4 integration of 4x plus 2 upon root 2x square plus 2x plus 1 plus 5 upon 2 integration of 1 upon root 2x square plus 2x plus 1. So this is our I1 and this is I2. 3 by 4 I1 plus 5 by 2 I2, where I1 is this and I2 is this. So take I1 and integrate it using the formula f dash of x upon root f of x dx is 2 root f of x plus 2 root f of x plus c. So 2 root 2x square plus 2x plus 1 plus c. Now take I2. Here the coefficient of x square is 2, so we have to take away the 2. Then we have to adjust the last term as 1 by 2 coefficient of x bracket square, that is 1 by 4. So 1 by 4 plus 1 by 4 minus 1 by 4 will gives us x plus 1 upon 2 bracket square plus 1 upon 2 bracket square. So 1 upon root x square plus a square, and its integral is given by uh, log of modulus of x plus root x square plus a square. So I2 is equal to 1 by root 2 times log of 2x plus 1 upon 2 plus root 2x square plus x plus 1 by 2 plus c2. So writing these terms together, 3 by 4 into 2 root plus 5 by 2 into 1 by root 2 log of this term, where I am replacing this c by 3 by 4 c1 plus 5 by 2 c2. So after simplifying here, we get 3 by 2 root 2x square plus 2x plus 1 plus 5 upon 2 root 2 log of modulus of 2x plus 1 upon 2 plus root x square plus x plus 1 upon 2 plus c. Okay, so we will again meet on the same exercise in our next lecture. Today we will stop here.